Last time, Qubit told Quantum they were starting a journey of quantum discovery.
You know, Quantum, this is probably humanity's greatest inquisitiveness achievement. It's a world so tiny it can't be seen unless the most advanced technology is applied. It's driven by complex numbers that we can't even imagine.
Wait, what? Complex numbers? I can only count to 3, so why teach me?
I was going to say, the good news is none of that complex numbers nonsense concerns us. You don't need to count beyond 1 to appreciate what a wonderful time of discovery is upon us.
So what is it, and why are we doing this?
It is the application of quantum theory to the field of communication and computation. My human is determined to learn about and to use quantum computers. He started by finding the 2 most referenced textbooks on the subject. It turns out my human is not as smart as I thought he was. He spent hours trying to understand. He doubled down until his mind exploded. But he didn't give up. Swallowing his pride, he started with quantum physics for beginners and is now taking more advanced courses. He is as determined to work with quantum computers as he is to get people excited about this fascinating technology. Currently, the best way he can contribute is to share what he learns in a humorous, compelling, and well-informed fashion, and that is where you and I come in. Today, I'll tell you about qubits.
You mean there's more than one of you?
I'm not talking about me. I'm talking about the bits of quantum information.
Wait, if this invisible world can only be seen with the latest technology, how did it become such a long journey?
You might learn to count beyond 1 if you continue asking good questions.
Hey, that's not true.
My human says I can count to 3 because I don't leave the breakfast nook until I get my 3rd sausage.
Did you say sausage? I love sausage.
Might your human give me some?
Stop with the food, I can't concentrate. Let's get on with your lesson. Your question is a good one. Let's make that today's subject. The origin of quantum understanding. It is argued by some that the earliest ponderings about a subatomic world date back some 2,500 years, when Democritus and Leucippus suggested everything was made of tiny particles.
Leucippus?
The cat next door? You're impossible. Pay attention, will you?
They called these particles atomos, though the concept of earth, water, air, and fire dominated such thinking at the time. 100 years earlier, in ancient India, the same question was raised with the word atomos replaced by anu. The Islamic contribution to math and science laid the foundation for scientific approaches to questions about matter and consciousness. And in Europe, in the 13th century, Thomas Aquinas helped usher forth Western scholarly and scientific research and exploration. With the invention of microscopes and telescopes, scientists, risking their lives, looked outward and inward to answer questions about our place in the universe. Until then, the answers were theological in nature. It was as if all the learning, discoveries, and research coalesced to usher forth the age of quantum understanding. Interestingly, they discovered behavior never seen or even imagined. Light traveled in waves, but also as particles. Quantum particles disobeyed the laws of gravity. They transformed from state to state for no apparent reason. A particle could tell you about the state of another, but then the other would die. What the world's brightest minds had difficulty believing they could prove mathematically, and thus was born the long-lived expression, "We don't know how it works, but it does." It was an explosion of knowledge. Max Planck introduced us to Planck's constant. Albert Einstein explained the photoelectric effect. Niels Bohr developed the model of the modern atom. Louis de Broglie demonstrated the wave-particle duality of matter. Werner Heisenberg left us with the uncertainty principle. Erwin Schrödinger has us wondering if the cat is dead or alive. And Paul Dirac established his notation in the form of a bra cat. Since then, physicists, mathematicians, and engineers, thousands of geniuses, have built upon daily discoveries, theoretical and practical, that have brought us to the present. We are now equipped with nearly all the tools necessary to capture, control, program, and sense ions, electrons, and atoms in order to exploit their properties, resulting in calculations completed in seconds or minutes that today's fastest computers would take billions of years to complete. What is most wonderful isn't that computers will reach unimaginable capabilities, or that medical, transportation, energy, and so many more industries will benefit from quantum mechanics. No, what is most wonderful is that all the learning and research that has brought us to the brink of a quantum revolution has been a collaboration by individuals from likely every country in the world who are eager to share their discoveries to enable progress. Success has been the result of collaboration, not domination. Now that you know how it all got started, next week we'll learn about the basic building block of quantum computers, the qubit. Bye quantum, bye qubit. Will quantum learn to count beyond 3? Will qubit stick to his project? Will qubit's human ever write an algorithm? We hope you'll join us as we learn.